Hello everyone, it's Professor Connor. I am here to make this video because I've had a lot of emails today regarding the math and a couple questions on the post lab. So I figured I would address it using this because I can go through the problems easily and go through some of the questions that I've seen coming through in my emails as you were doing the post lab. So I'm going to share my screen here so that we can get started and move right into what we are doing today. So here is your post lab. I'm just going to make it a little bit bigger. So we have two questions we're going to go over. So we are going over the third one. So the soft drink Mr. Pibb contains, I'm going to make that a little bit bigger. Zooming in just a bit more. It's hard to see. Maybe I'm just old, but we'll make it a little bit bigger. Hopefully that's better. Yeah. So the drink Mr. Pibb contains, among other things, 39 grams of sucrose in a 355 milliliter solution. What is the molarity of sucrose solution, and what is the percentage weight divided by volume of sucrose in that solution? So we're going to go over that question. I'm also going to go over number 6. How do you prepare a 500 milliliters of 0.1 magnesium sulfate from a stock solution of 2 molar solution of magnesium sulfate? But I do want to address this down here. So this is another question I've seen a lot of people have on. So in this question, they are asking you to determine which is the most effective buffer and which one is the least effective buffer. Well, if we're looking at our list, this is kind of the kicker here where it can be very deceiving, because if you look, we already have a buffer in there. So we use the 0.1 molar solution of phosphate buffer as, let's say, our positive control. It will show us what will happen if we have a buffer that works. So obviously a buffer that's meant to be a buffer is going to work super well. So we have the initial pH of 7, and as much hydrochloric acid as we add, the pH is still going to stay the same. So that gives you your baseline of what it should look like if you have a really good buffer. So then that leaves two other pieces on this assignment or on this list: water and skim milk. So obviously, skim milk is the best buffer of the two because the pH doesn't change even after we're adding the acid. So if we're looking at the most effective, of course the buffer is going to be the most effective because that's its job. But if we're looking at water versus skim milk is definitely the better buffer of those two. Water, on the other hand, starts at a pH of 7, and then after you put the acid in, it moves down to a 2. So it's not pulling anything back at all. A buffer, as we know it, actually makes sure that whatever the pH is initially, the buffer keeps it at that initial pH and tries to keep it in that range. And your body has a lot of those areas where that buffer is included to keep it at a pH that's needed in that specific area. So that's that question. If you have questions on that, let me know. Let's just get into our soft drink question. So I'm going to minimize this because I do have it right here, and I'm gonna make this a little bit bigger. So here is our question. I've kind of summarized it a little bit. So we have 39 grams of sucrose in that Mr. Pibb and 355 milliliters of solution. The question asks us what the molarity is and what is the percentage weight divided by volume of sucrose in the solution. So the first thing that we're going to do is we have to convert the sucrose into moles. That is the weight that we're using. So we have to look at the periodic table and use that to determine how much of each of those particular pieces we are using, or how much it weighs. So we have the molecular structure, the molecular formula for sucrose, which is C12H22O11, carbon, hydrogen, and oxygen. And so we look at the periodic table and we look at each one to find the molecular weight for each individual mole or element. And so for carbon, if you look on the periodic table, it is at a 12, and we actually have 12 carbon atoms. So we're going to do 12 carbon atoms times the molecular weight, which is 12, and we get 144. That's where that number comes from. Hydrogen is at 1.009, and if we round that, it's going to be 1, and we have 22 of them. So we're going to do 1, which is the molecular weight. times 22, because that's how many we have. And so we have 22 grams of that. Oxygen, if you look on the periodic table, is 15.999. So we're going to round it to 16. And so we have 11 of them. And so we are taking 11 molecules times 16, which is the molecular weight for each, and we get 176. So overall, our weight for sucrose is 342.29, or we're just going to leave it at 342 grams. Eventually it's Dalton's, but we change it into grams to suit the purpose of this problem, right? So what we do now is we have 39 grams up here. We have to figure out exactly how much moles that is based on the total number a mole is. A mole is for sucrose is 342. So we're going to take what we have and divide it by what it should be if it was a full mole. And we do 39 grams divided by 342 grams, which gives us 0.114 moles of sucrose. So once we get that, now we can kind of put it into other equations. We're going to look for molarity. Molarity is moles per liter. And so we're going to take our moles of sucrose, which is 0.114, and divide that by the amount of the solution in liters. So we start with 355 milliliters up here, so we have to convert that down to liters. So 355 milliliters, if we're converting it, ends up being 0.355 liters. So now we have our units that we need for molarity, because molarity is moles divided by liters, or moles per liter. And so we have moles per liter here. So now all we have to do is our math. So we take 0.114, we divide it by 0.355, we get 0.3211, or 0.321 moles per liter, and that's our molarity. It's 0.321. So when we're looking at the percentage, we're going to take the weight we end up with, which is still 39 grams, and we're going to divide that by the volume of our solution. So we have 39 grams, and that should say 355 milliliter solution, not grams. I apologize for that. So we take 39 grams, and we do 355, and we equal that out to 0.1098. And we get about 10.98% of that solution is sucrose. So that is the first problem. It's been a long day, so I apologize if I kind of rushed through that, or I might have had some misspeaks here and there. But that is how you do the math of that problem particularly. The next one that I'm going to go over, so this was number 3. The next one I'm going to go over is number 6. This question asks how you would prepare a 500 milliliters of a 0.1 molar solution of magnesium sulfate from a stock solution of 2 molars of magnesium sulfate. So we are going to use our diluted problem for this. So the actual equation, there we go, sorry. The actual equation is MIVI equals MFVF. And what these mean is the M represents mass that we initially start with. So the I is initial. So mass initial times volume initial. V is for volume. And that equals to the mass final times the volume final. So we have to go back through our problem and determine which ones are which. What are we starting with and what are we ending with? So we go back up here and we say, oh, we're going to prepare a 500 milliliter solution of 0.1 molar solution of magnesium sulfate. So that's where we're headed. So we know those fall into the final side. And then we're taking from a stock solution of 2 molars. So I have made me a little bit of a cheat sheet for each one of these. I'm assigning these pieces to each one of the pieces up in the equation so I can plug them in. So 2 molars is my initial mass. So we got that from here because we're coming from that stock. And so I have 2 molars here. I do not know the initial volume that I started with. So that is my unknown. That's what I'm going to try to get by itself. I have the mass final from the equation, or from the problem, so I have 0.1 molars. So I'm going to put that in for that particular piece in the equation. And then I know what my final volume is. It's 500 milliliters. So I have my pieces. Now I'm just going to plug them into the equation. And so as I'm looking at this equation, I'm plugging in each one. So the initial mass is Initial mass here, 2 molars, so I plug that on that side. We do not know what VI is, the initial volume, so that's going to be the one we want by itself eventually. We know what the final mass is. It is 0.1 molars, and we also know what the final volume is. It is 500 mils. So as we plug those into our equation, now we just do a little bit of algebra and we move things over, and we want to get the initial volume by itself. So I'm going to take this, I'm going to do the algebra piece. What I do to one side, I do to the other. So I take 2 molars. These will cancel out. That leaves that initial volume all by itself. What I do to this side, I do to the other. I put 2 molars down here. The molarity basically cancels out, and I'm left with 0.1 times 500 mils divided by 2. And now I'm going to make this as easy as possible as I can. So I'm going to make these, I'm going to reduce them down. So I do 2 is reduced to 1, and then 500 is reduced to 250. So my final problem, this goes away. It's basically a 1, so I don't need to count on it anymore. So my final problem becomes initial volume is equal to 0.1, because that got dropped earlier, times 250 milliliters. So I multiply that out and I get my final volume as 25 milliliters. So hopefully this will help you decide how to do additional problems. Remember, you're always looking for what you're starting with and what you're ending with. And whatever that is, you just try to get it by itself in the equation. All right. So hopefully that has helped you be able to get through some of the math. If you're still having issues, let me know. I've had a couple people email me about this math. It's been a while since some of you have taken maybe some chemistry or even done a little bit of this in other classes. It's not an easy thing to remember, and you'll get better at it as you practice. So if you have more questions, let me know. Email me. I try really hard to respond to your emails as quickly as possible, usually within 24 hours. Of course, weekends or weekends. But I am here to help. I'm here to make sure that you have all the tools that you need to be successful. So if you have questions, again, let me know. I'll get back to you as quickly as possible, and I hope you are staying safe, and hopefully next semester I'll see you on campus. So if you have anything else, let me know. Have a great night and see you later.